So a few months ago, I created this. A Redstone hard drive built in Minecraft, using the idea of a copper bulb as a storage unit because it's a flip-flop, so you can store something to it, and then making it into 8 copper bulb for 8 bit or 1 byte, and then stacking it into 45 into a feed tape shape so you can cycle it around to access a different address. The copper drive is great, but it has some problem. First of all, the size. The capacity of this copper drive is 45 bytes or 45 addresses, but let's just say we want more. So of course, I make it into 64 bytes or 64 addresses. With this new one, we can store a lot more stuff to it. And second, the feed tape is not optimized enough. So let's just say it's currently reading from address 0, which is right here. And the user wants to access to address 44, which is right next to it right here. But if you see at the feed tape shape, it can only rotate in one direction. So in order to access this address, which is 44, next to the address 0, it has to cycle 44 times to access it, even though it can access it by shifting once in the opposite direction. So let's see what I mean right here. So decrease, and then let's access address 44 like that. It have to cycle around 44 times to just access that address. So in version 2, I make it so it can shift in 2 directions. So as you can see here, it can shift to the right and to the left. Yeah, that's really cool. And it will improve the overall address seeking time by a lot. And the next thing is the read and write arm. As you can see here, there are 2 of them. This one is for reading, which use the comparator, and this one is for writing, which use the repeater. And you can see here, they both are pointing at a different address. It currently reading from address 0, but it currently writing to address 44. And it caused some problem because they are not the same. One of them is the need of 2 counters, because one you need to track what currently it's reading on, and another one is to track what currently we writing on. And with that too, we need another bit to control whether we want to read or write to the feed tape. So to solve that, I make this module, which allow us to write and read from the same address. So as you can see here, it reads to the same address that we write, unlike the old one, which are different. See, it's a lot different. So now we only need just one counter to track what the address is the arm pointing on. And by the way, credit to Stickman for creating this up and down counter. Alright, so another improvement that I made, that in the old version, you need to wait until the seeking process is completed, meaning you have to wait until the correct address is found before you actually input your data, because it might end into the wrong address. So to fix that, I added a write buffer. A write buffer is just a thing that holds your input data and input it into the hard drive until the correct address is found. So for example, let's say we want to input to address 8, and then we input our data, so maybe like this, and then write. And then the hard drive will wait until address 8 is found before writing to the hard drive. So yeah, there it is. The data is written after the address 8 is found. And did you notice it that the input module is now unreasonably humongous? Well, because I added something that made things a lot easier. So you know, right, copper block are T flip-flop, because when it receives an input, it's just going to toggle itself, unlike a D-latch, which are going to store the input itself inside of it. And T flip-flop is definitely different. So when we input a number 10 to it, which is 1010, the result will be this, depending on the contents in the address before. And in the new version, the input module will automatically clear the address first before writing the data in. So let's see what happens when we input 10. 1010 and clock, clear, and then write. Let's input whatever this number is, and then clock again, clear, and write. Nice. And with all of that, we finally got ourselves copper drive V2 with faster storage system, higher capacity, and of course extra features like the write buffer and T flip-flop handler. And now we finally got ourselves a better working hard drive. Why don't we run defragmentation to it? Like, we will connect this into a CPU, and the CPU will defragment this hard drive. It will really cool, right? So now the hard drive is connected to my CPU, and the code pasted in. So the algorithm is pretty simple. It's just going to find any scattered data, which is non-zero data, in the feed tape, and then clump it together into a single spot. So it's for faster access. Alright, let's just start it. And now let's just wait. And finally, after a very long time, it's finally done, dude. Look at that. Every scattered data in the feed tape is clumped together in here, which, yeah, it's for faster accessing time, you know, some stuff. Alright, so I guess that's all for the video. Thanks for watching, and see you later. Goodbye.